On today's episode of Future Says, we have Chris Wlezien, Senior Expert and Design Director at McKinsey. So Chris, tell us a bit more about yourself and your role at McKinsey.
Well, thank you for inviting me. I'm really excited to be here. So I lead our physical product design practice. I'm an engineer by training, but have spent so much time in product design and development. I've kind of covered the gamut of industrial design, research, and really at McKinsey, kind of business strategy. So at McKinsey, I kind of lead the intersection of where technology and those business decisions come together. So I go in and try to help clients better understand and make technical decisions that drive their business in the right direction.
Okay, and tell us about what you're working on at the moment. Any sort of interesting projects?
So that's something that's really cool about my role. A lot of people in consulting work in like specific sectors. So they'll only work in med tech, for example. But as a senior expert in the product design group, we work on everything. So we work on medical devices, automotive, industrial. I've worked on a lot of power systems and energy stuff recently, electric vehicles. It just spreads across things. And I really like to say it's because the physics is the same. The injection molding is the same. The manufacturing is, similar. There's some differences, but we can take these insights and spread them across all these different industries. And it makes us able to bring in really interesting insights to clients that may not have otherwise been aware. So something I worked on that's really interesting recently was a consumer fast food restaurant. They had this really disparate packaging. They're a smaller chain, but still pretty successful, have this very disparate packaging that kind of didn't look right. It was all these different materials. So we came in, I was not really optimistic that we're going to find a lot of savings opportunities or opportunities to change the packaging, but I was totally blown away by what our team did. They came up with all these great ideas to make the packaging look more cohesive, make it easier for the consumers to eat their fries and their burgers, make it easier for the fry cooks in the back to package things up, make the food hotter, fresher, longer. So I was really impressed that we were able to both reduce the cost for our client and come up with a really compelling concept. And one of the things we did, and we'll talk about in a few minutes, is use some cutting edge tools to get that done.
Yeah, and exactly on that then, what are some of the cutting edge tools impacting all of these different industries at the moment?
Yeah, so it's really interesting. We're definitely going through a transition right now. So I've been in product development and design for over 15 years and have kind of run into all sorts of different problems and challenges and done things by hand way and the computer aided way and individually and in teams, and really have a really broad perspective, especially because I've been helping clients along the way. I've helped over 100 clients in my career. So I've really seen a lot of ways of doing things. But recently there's been some really big advancements in generative AI product development and design, specifically on the front end. So there's all these new tools, we'll use the large language models that we're all familiar with to come up with insights. So if there's a new problem we're trying to solve, maybe we're coming up with a new beverage, a new bottle of tea for a new market, we can ask these large language models how to innovate in the space or how to come up with a new concept or what consumers might care about in that area. And it really helps us brainstorm and generate new ideas. So it really just helps us to get to answers faster. Another big tool we've been using that's probably more impactful still are these image generating programs. So there's quite a few of them out there that you can input language-based commands and they'll generate sometimes even photorealistic product concepts. And they're certainly not without their issues, but they can really help accelerate the product development process. So what would normally take us weeks to generate a high fidelity image of what a future blender might look like, we can put into one of these image generation programs and it can generate in seconds. So yeah.
Wow, amazing. Another one that I hear a lot talking to our engineering clients is, of course, like you've said, generative AI, but they also speak a lot about digital twins. We had somebody from Nokia today speaking about the metaverse. How are digital twins impacting design and engineering today?
Oh, yeah, digital twins are huge. So let me actually preface with one of the first programs I used was a topological optimization tool, or just a generative tool that allowed me to do FEA, static simulations, more effectively. So it would take the inputs and the loads and design the part where it should be so we can optimize material that way. And that's something we've deployed even at McKinsey for a long time now. But these new tools and digital twin have really streamlined and created some new opportunities in FEA. So we recently helped a client that makes turbines, power generation turbines, build a digital twin of their turbine, and we're able to quickly generate thousands of concepts and actually find some pretty appreciable savings, big number savings. And especially when you're in the power generation business, efficiency is everything. So we were able to build this model and really improve their operational efficiencies it was a huge impact for them.
Hmm. And so when we speak about generative AI, is that leading into generative design?
Yeah. So yes and no. So on the digital twin side, we're building custom models from the ground up. We're training them. We're building that model in house, and we actually have an internal data analytics team we bought called Quantum Black
Okay.
that helps lead that for us. I actually don't work as much with that personally, but on the generative product design, generative concept generation, that's more of what I do on the physical product side. And that is actually like an external tool or external tools we use. So we're not building our own models, but we're leveraging these awesome tools other people are building to, like I said, accelerate our workflow so we can generate concepts in hours instead of weeks.
Wow. So I know, again, speaking to automotive companies, they've spoken a lot about trying to completely transform the product design now. So using generative design, you can move from what is typically a 5-year life cycle to a 2-year life cycle.
Yeah, I mean, I think ultimately that would be a great goal. I have not seen any evidence that their tools are that advanced. So again, I'll use the example of these concept generation tools. We recently looked at doing an automotive interior for an electric vehicle, and again, it would have taken our team weeks to come up with the level of detail these tools can generate in hours. Now, granted, they're not bulletproof and they need to be refined, and we never take anything that generative design makes into production, but it just helps accelerate our team. So I can definitely see a time in the future where these product life cycles can come down that effectively, from like 5-year to 2-year period. But I personally don't think we're there yet. I haven't seen evidence that we're there yet. But
And you say the generative designs then are never going into production. So the whole purpose of them is just generating ideas, which can be tweaked, which can then be put into production. Is that right?
oh no, absolutely. So again, like that also kind of helps insulate the work and really help our team shine as well, right? Like by using these tools as inspiration, they can really help us accelerate. They can also help us. One big use case for us is to generate these concepts and then bring them to research. So we could bring them to closed focus groups or testing where we can see what consumers think of them. And that's something you want to do super rapidly to get to insights as quickly as possible. But yeah, typically when you're going to be going to the level of detail you'd be going to in production, we're going to be building those designs from scratch the old-fashioned way, at least for right now. And I'm not saying that's not something we can do in the future, and I'm sure that will happen in the future, and I'm very excited for that, but we're just not there yet.
Yeah. And what is that? How do we get to that future? What challenges exist today that you need to overcome in order to get to that future?
I mean, honestly, and again, software is not my specialty, so let me preface with that. But honestly, I do think it is probably just more advancements, more use, more development of these tools. So right now, they're very basic. One example I constantly use is I had at least one email or phone call a week in the summer about, do we have any generative AI tools that can take words or a sketch and turn it into a 3D CAD model for manufacturing? And we've been scouring the internet trying to find partners, and we have not found anyone who's doing this really successfully yet, besides like taking a concept and making like a point cloud data with it. So we're just very, very far from that. And that would be a huge unlock because you could take that long CAD window and really shorten it down and improve your development that way. And then I'm imagining a future where not only does it help create the model, but it can create like a DFM model that's designed for manufacturing already, that's seamless, and it's like much closer ready to go into manufacturing. So it should speed that process up tremendously, but we're just not there yet. And one thing I think is fascinating, and why I'm so confident it will happen, is because a lot of these tools exist already. There are integrated tools for DFM, for wall thicknesses, drafts. You can estimate material costs or part costs with these integrated tools, but I have not seen examples yet where GenAI is doing this. So I'm sure it's just over the horizon, and I'm sure a lot of these software development companies, including Altair, are thinking about this very heavily, but I just haven't seen any evidence of this yet.
Yeah. So 15 years in product design, is that right?
Yeah.
Is this the time you've been most excited?
I have to temper expectations. I think I was most excited when 3D printing went mainstream, because that was always such a joy for me, even learning about it before that happened and using it a lot in my product design. So I could talk to all my family and friends about how it works because I was so familiar with it. But honestly, this is definitely up there. Like when topological optimization, when we started getting a hang of that and helping our clients with that, the unlocks were just so big. And so I'm seeing that as well here. Like the clients are just blown away that we can come up with these concepts so quickly and then like get them into prototyping and have them in consumers' hands for testing in like a week, which is just unheard of. So it is very, very exciting.
In terms of those sectors then, Is there an industry that you think are the earliest adopters of this next generation technology?
So as far as sectors go, I think the consumer sector, I've seen a lot of push in. We have a few team members who are pretty much exclusively doing Gen AI now as part of their work, and they're doing a lot in consumer. The like you said, the cycles are just so much shorter. The development cycles are shorter. Really, the risk is shorter. If you're making a water bottle, it's certainly less risk than designing a full vehicle, right? So I've seen it more in those sectors, and then by nature, like less in the medical sectors. But I don't know if there's any sector that's not being impacted by this technology. It's coming up quicker in some of these lower risk sectors, but I think everyone should be aware of them. And I can't think of a single sector that wouldn't benefit from it. Because even like you said with the digital twin, even like industrial sectors where there's no consumers to speak of, and I don't have to, like, you just design everything in the simplest means possible to achieve a goal, there's still optimization to be done.
Yeah.
So
You touched on 3D printing. I feel like 3D printing hit the mainstream and then has kind of hit a plateau in years, but really is taking off again now. What's your viewpoint on 3D printing? And
So yeah, I'm absolutely. This is one of my favorite topics, honestly, because I've always been inspired by 3D printing, and it's been such a critical part of my product design workflow for my entire career. Now, I do think it's the constant evolution in 3D printing has been amazing, and like seeing these steps and seeing when like the original patents were released, and then consumer 3D printing became a thing. But I think the interest was solely on that push from industrial to consumer that we saw. I think it had been like the 2010, 2012 range. And that was like a little inflated. Like at the time, I was working for another product development company. We did a research report on the prospects of 3D printing. And actually it was more grim than what people thought. And they assumed, I think with my product design background, we'd be more excited. And it's true, I was very excited. But there was this sentiment that, hey, there's gonna be a 3D printer in every person's home and we're not gonna need to manufacture anything anymore. And we just knew that wasn't physically possible because like the economies of scale aren't there. They're not fast enough. They can't make every material you could want. Like maybe there's one day where a 3D printer can make like a laptop from the ground up by arranging atoms. And then that would totally revolutionize everything. But right now, 3D printers are excellent in product development and great in some medical applications where you have to make like a custom hip implant or a custom piece of someone's skull or something like that. But I think they're quite limited in how they could work in mass production right now. And so I think that was the issue, is that people weren't really familiar with it. Then everyone became familiar with it because of the exposure on the consumer basis. And everyone got really, really excited, which is great. It's really exciting. I was very excited, but I think that set an unrealistic expectation. And yeah, now it's becoming more and more popular because there's all these advancements in material science. There's all these different like processes and materials and types of printers they can use. I've seen some resin printers that can print. You can like watch the part coming out of the 3D printer. It can come out so fast, and that's really competitive for like high end like aerospace applications, or I guess even like sporting equipment, places where people would pay for those kind of premium features you can get with like a 3D printed part. But in like a consumer market where you're trying to make a water bottle, just keep going back to that example, you could never, I can't see a future where you could 3D print a water bottle cost effectively. Yeah. So I think that's one of the big challenges.
I mean, that still boggles my mind. I think when I speak to engineers, they speak about 3D printing as if, we just 3D printed this part. That's easy. But when I speak to my friends and I tell them those things, they're so amazed. So I still think in general in the public ecosystem, this is so revolutionary.
You know, and it absolutely is. Like I said, I don't think there's a topic I'm more excited about personally. So just let me start with that. But I really think the two things you have to think about are speed and cost. And they're just getting more and more. They're getting faster and faster, and they're getting lower and lower cost. They're getting more competitive on cost. But I just don't see it getting to the point where it's going to match traditional manufacturing methods, anytime soon. But I think that's okay. Like I said, there are plenty of applications where 3D printers are replacing hips and making like mouth guards and all sorts of like sporting equipment, customized stuff. They're absolutely amazing for that. But I just think that's like they really limited in their application base.
Is there an overlap between 3D printing and generative AI? Is there a play there?
Oh, certainly. Especially when we talk about the topological, the FEA, making these optimized shapes. Oftentimes, the best physical shape to make like a structural component is not an I-beam. It's like this really interesting triangulated organic shape, and it's really hard to make those with traditional manufacturing methods. when we do our topological optimization for clients, we often have to take that as an insight and then bring it back to something like injection molding or die casting. But now with 3D printing, you can make these optimized shapes and then just print them. That you can print anything you can imagine effectively with 3D printing, where you don't have to worry about parting lines or draft or any of those technical requirements that the typical manufacturing processes have. So yeah, they really enable like making really creative shapes and really creative things. And also, I mentioned maybe once before, but when you have this generative AI concept, you can make it really, really quickly. Then you can also 3D print it extremely quickly compared to the original model making processes. So you can go from an idea to a physical thing in a week, which is just, unheard of 30, 40 years ago.
Yeah. So how does an engineer watching this and hearing about all these new things, how do they stay up to date? How do they ensure that they're still at the cutting edge today, tomorrow, the next day?
I think there's a couple of ways to answer that. So personally, on an individual basis, I would challenge everyone to just be as curious as possible, like have that child mindset of, if you see something that's interesting and that inspires you, just explore it and think about it. There's so many new technologies, and going to CES and seeing all these different technologies, they're almost endless. So you really have to give yourself the intellectual freedom to just explore and look into these things and think about if they could work for you or how you could employ them or what you could do. And honestly, I think for corporations, there's a big opportunity as well for leadership. I think they can create an environment where employees don't have to be afraid to share ideas or try new things or explore areas that are a little bit more risky. So I think at the corporate leadership level, creating incentives to try new things and explore and innovate and have room to fail is paramount. It's really, really important. And on an individual level, it's just about exploring your interests and your passions and following where your natural curiosities lie. Because I think we're all engineers, scientists, designers. We love what we do and we get excited about it. And I think sometimes our biggest challenge is ourselves saying like, no, you can't die cast that. And we only do die casting. So don't think about it. No, it's like you have to think about it because the future is obscure today, right? Like I can't remember the quote, but it's something like every truly advanced technology is, seems like magic to a previous generation, right? It's like the future is always going to look obscure and kind of strange. And sure, 95% of things are going to fail, but those 5% that make it through are going to change everything.
All these different types of technology all seems very successful. Over that 15-year career, have you investigated pieces of technology and thought, you know what, that doesn't help me? And we hear so much about technology. There are misconceptions about technology. Have you had any difficulties through the years?
Yeah, I mean, absolutely tons of difficulties, pretty much consistently. Like even like I mentioned on the generative design part, like everyone wants a program that'll just make CAD models and CAD drawings and manufactured parts from the get-go, but we're just not there yet. Though I do believe we will be one day. But akin to that, there have been all these challenges over the years of people thinking we could do things or achieve things and struggling. Like one of my favorite examples, I didn't personally work on it, but if you remember back in the day, 3D TVs. 3D TVs were a huge thing at CES. I don't know, 2015. It was everywhere, and they just never really panned out. I think there was lack of interest from the consumer side. It was hard to generate the content. By nature, innovating is a challenge, and most technologies will fail. And I actually think it's an interesting testament to humanity and our willingness to accept the challenges of innovation, that we're okay with that. Like I've worked on tons of products that didn't get a lot of traction. I loved seeing them in the store, but they were only there for 6 months to a year before their like sales were a little lackluster and it didn't work out. And I think it's like it's a testament to our creativity and our desire to always be trying new things. Like when things stick, they really stick, but if they don't, we just kind of move on.
You're giving lots of great advice here and being curious and investigating and trying new things in your career. Have you had different pieces of advice that have really stayed with you?
Yeah, I think a couple of things I would like to share on that regard. One, from like a management perspective, I've really kind of thought about and refined my management and how I work with teams. And it's something I see, I won't say a lot of managers miss on, but not really codified super well. So I think there's really 3 core aspects to managing a team to be successful. One is kind of like driving and setting a goal for the team. So setting expectations, that's how you keep things moving in the right direction, how you make sure the team's all working on the right things. The second is removing roadblocks and making sure they have everything they need to succeed, whether it be software or the bureaucratic red tape of getting something done, or support to try something new, to go out there and explore and fail. So just supporting them. And the third, probably overstated often, but potentially even understated, is mentorship. Just making sure the team really knows they're supported and you have their back and you have the door open and they can come to you with anything. I find that often, like, it's sometimes in the work environment, it's hard to have that relationship and have that support with your team members, but that honesty and understanding really goes a long way for being successful.
So talk to us now about the future. Good team, lots of technology. What are you going to be working on over the next 12 to 24 months?
Oh, man. So 12 to 24, in all fairness, I think we're going to be doing a lot more of the same. Generating better concepts, coming up with better ideas, pushing the envelope, and using a lot of these new tools to, advance our concepts faster than we ever could have before. But if you may, I am much more excited, and I'm up at night thinking about where we're going to go in the next 5, 10, 15 years. So I imagine a world where, and I know this might even scare some people, but I imagine a world where we all have like embedded computers in our brains, direct to brain computing, and designers and engineers can sit in the room and just kind of think about concepts, and they can all show up in a VR mural board. And then you could automatically do DFM and simulation and cost models and have something for user research immediately. Maybe you could have user research done virtually in the same fashion, and we just get to an answer. So we get rid of the mundane, like spending, I can't tell you how many times I've spent like 4 hours trying to figure out how to make a round work to get a 3D model, a corner of a 3D model to converge properly, or an FEA model to converge and not keep failing. So getting rid of all of that and just making like the engineers and designers really just curators of creativity. How can we get that down to what humans are really good at?
And the big value out of that utopian future is increased speed, increased efficiency, better product designs?
Absolutely all of those. But I also think just better engagement, people doing what they love, what they're passionate about, what they're excited about.
Anything scares you of that future, or it's all good?
Oh, no, there's going to be challenges along the way, certainly, and a whole bunch of things we probably haven't thought about. But that's like the beauty of being a futurist and into sci-fi, is we can think about the positives and work towards it. But then, obviously we have to be aware of the challenges as well.
So when we speak about generative AI then, Chris, what are the limitations? It all sounds great, but what are the limitations of these tools?
Yeah, so I think one of the limitations is actually something I've dealt with throughout my career as a product designer. So we often have this rule that the I call it a prototype, but a prototype can be many, many things. But the prototype you have and the quality of that prototype should reflect the level of confidence you have. So for example, if you have an idea for like a new latch mechanism, it can be a Post-it note and you show someone that and they kind of get the idea that, okay, this is a really new idea. But with some of these generative AI tools, you could say like, oh, hey, make me an image of this latch mechanism. And it looks like you're totally done because it's photorealistic with lighting and shadows. It looks like it's ready to go into production, and it's not. So I think that's one big challenge, is these tools make concepts look really refined when they aren't. And so as our job, and as the article we published kind of details, we as designers and engineers, we're more of like using these tools to advance the concepts and the ideas more than we are letting them dictate what the final output is. So yeah, these tools, they create really interesting, compelling concepts that are really refined but not detailed. So for example, we often lack what I would call like consumer emotional empathy. So we might have an idea for a bottle, let's say, that is this tall and this wide, but maybe it really doesn't fit in someone's hand, or maybe it's not the right shade of a color, or maybe it's not manufacturable, or it doesn't have all these details we need. So really, that's also why I mentioned that these tools really can't be used to go right into production. They're great for creating inspiration and giving us something to start with, but they really leave a lot to be desired in terms of like the details and the depth. And so I also think that's something that's going to improve as we go forward, but it's just not there yet.
I think that's where the engineer comes in. It's called generative AI. It's generating ideas, but the creativity at the end of the day is still in the hands of the engineer. Would you agree with that?
Oh, 100%. Absolutely. I couldn't have said it better myself. Like, these tools, they allow us opportunities, but they don't provide the answers. I like to think of it, and when I'm describing it to people, as what CAD did to the world of drafters. It didn't eliminate the engineers or eliminate the drafters fully. It just helped accelerate them and give them new tools to do things faster, more effectively. Or like photo rendering tools. Like before that, I actually don't even know how you would have made a render before that, but you can, do that much quicker with these tools. So it's really just a tool to enable a successful designer and engineer. But people often ask me, is this going to replace all the engineers and designers? And I really don't see an avenue where it does. I think it just makes everyone faster and makes companies more efficient and makes products better at the end of the day.
In your customer projects, are there engineers like that are resistant to change, though, resist to work with you because they are concerned that, hey, all this guy wants to do is take away my job and automate things?
I wouldn't go that far, but there is, especially on some of my client side, a lot of hesitation to using these tools. They either don't really trust the concepts or don't trust, like in the topological optimization side, they don't trust the output of those FEA analysis, but we'll use traditional manufacturing, testing, design processes to show them that the outputs are good. Like we talked about a minute ago, these tools, they work great with 3D printing, but it doesn't mean you have to. We can still take the output and modify it so that the inspiration's there, the thoughts are there, but you could still go to more traditional manufacturing methods or traditional processes. So yeah, I think there is a lot of apprehension, but there also are answers. And I think it actually stems from the point that people are kind of jumping ahead of where these tools are. Like they're imagining that they can do all this DFM and CAD generation stuff today. We're not there yet. Maybe we will be, but we shouldn't assume that we are either. Like we understand the limitations and we use them to the best of our abilities to make us better engineers and designers, but we don't, assume that they can solve every problem just yet.
Yeah. When I speak to customers about AI and partners, it's often about, again, saying, look, we need to start small. We need to prove the value of this. We need to get the people on board with the potential behind this. And once they're on board, then you can scale it. So it's about starting small, scaling fast.
Yeah, absolutely. And like I was saying, using the same process. So the first example, you can use these AI tools, generate the output, and then run that through the traditional verification and validation process so it works. And then once we get more and more comfortable, maybe we can start relaxing that verification and validation or accelerating that. And once we know the simulated model is as good as the real world, we don't need the real world testing anymore, but we're just not there yet. So we can keep pushing for that. That could be the future where, we don't need that physical testing, but for now we're just using this to accelerate and get there. And honestly, this is not very glamorous, but we've been using FEA for that for clients for a long time, or if our client is not very FEA simulation savvy, we'll go in and just help them with our capabilities and say, hey, look, you can reduce your testing here by simulating this beam structure. And, to you and I who spend more time talking about this stuff, it seems, second nature, but not every company has these capabilities or is aware of how you can use them. So I think it's just very much like that analogy as well. It's like there's a way to do it, and then you can vet it with your traditional methods. And then as you get more comfortable, start, consolidating those timelines.
I have seen companies pushing their organizations to say, no more physical testing. Have you seen that? Is that possible, do you think? Everything moving virtual?
Yeah, I mean, I think that would be awesome. And I think our models keep getting better and better. I mean, some of these like failure mode simulations I've seen are quite impressive, like the way things fail in simulation versus the real world. But I think it also depends on the risk level. Like sometimes it's, testing is not super cost prohibitive. So you do simulation just to accelerate to testing. Like you don't really need to give it up because it's not that expensive. Other times, like, testing a full scale rocket, it's very, very expensive. So you have to like move away from testing as much as possible. So I think like as the tools progress, we'll do that. But yeah, I think it'll just be kind of like a natural progression and not just like a light switch.
Yeah.
Though there is a light switch I would love to see. It's not testing. Drawingless engineering models, something I'm very, very passionate about. Not a hot button topic today, probably will never happen, but doing GD&T directly in the part file and not needing a drawing, it's very feasible. It's just hard to adopt.
Why is it hard to adopt?
I think traditional manufacturing settings really like those 2D drawings and their traditional workflows. I know of some applications in automotive or in aerospace, where they will do drawingless, but I just haven't seen it a lot because everyone likes those PDFs with the call outs and the dimensions in them. But yeah, it would save a lot of time as well.
Your job sounds pretty exciting, Chris.
Oh, thank you. Appreciate that.
Chris, thank you so much for joining.